So we are approaching the fourth and the last major AHU type, which is the dual duct variable air volume. And this is one of the most efficient AHU available in the system right now, available in the literature. So this will be noted as DDVAV, dual duct variable air volume. To start with the schematic, let's say we have an outside air which is coming. We have some return air coming, which is return air. These two air, outside air and return air, gets mixed up, and it is called as a mixed air, MA, which goes through a preheat coil, which is called as PH. And after the preheat coil, we'll have a supply fan. The supply fan supplies air to two different ducts, so that's the reason it is called as dual duct. And we'll have one of the duct which will have the cooling coil. The other duct will have the heating coil. Each cooling coil and the heating coil will have a set point temperature at which they are working. So usually the cooling coil is working at a 55 Fahrenheit set point, and heating coil can have a different values. So it can range from some 90 Fahrenheit to 120-130 Fahrenheit. And then this cooling coil and heating coil will give us hot and cold air, and this hot and cold air will be used to mix and supply to different zones. So we can have n number of zones, and this will be mixed up terminal box. This will be a terminal box, and in the terminal box the amount of cold air and hot air to be used will be calculated based on some calculations and control system, and then the return air will be coming after through some vents or some exhaust dampers, and will be going to the return air. So this is the return air which will have some temperature of TR, and the amount of air which will be mixed will be again based on a formula which is called as VJ QS upon 1.08 T of the zone minus T of the supply. Okay, I hope you have understood it. And now the amount of cold air and hot air to be used are to be calculated. So this VJ will be, so J denotes the jth zone, so first zone, second zone, etc. And the amount of cold air or hot air can be calculated. So if I want to calculate the amount of hot air, what I'll do is I'll take the temperature of the heating coil, leaving temperature, and the amount of hot air to be used can be calculated. If this turns out to be negative, then I do not need to use a hot air. If that, and similarly I can calculate the amount of cold air T zone minus TCL. So if my zone temperature is greater than TCL, then I need to obviously use my cold air. That means I need to cool up my building. And after we have the amount of cold air and hot air to be used, all other calculations are very much similar to what we have for the dual duct constant air volume. If these volumes which are to be supplied to the zone are very low, if they are below the level of the ventilation airflow which is required, then we'll set up this coil Then we'll set up this terminal box to control in such a way that that particular zone operates as a dual duct constant air volume system, because we at least want to supply a minimum amount of fresh air to my zone so that the occupants are comfortable with the amount of oxygen which is available in the air. And I hope it is clear to you. Thank you.